This is not a simple stone. This mineral that just looks like a stone exists in many things we use for our daily lives, for example, daily necessities or high-tech parts. The world concentrates on how high added values it can create with the natural minerals.
현재 주요 금속 관계 대부분을 수입에 의존하고 있는 우리나라의 경우 대폭각 금속광의 활용을 위한 전주기 개발이 필요합니다.
The Korea Institute of Geoscience and Mineral Resources, KIGM, focuses on studying more economic and efficient production technology for the advanced raw material industry, and contributes greatly to securing overseas metallic mineral resources. Mineral processing is a technology to separate valuable minerals and gangue minerals from their ores to create greater mineral values. Valuable minerals can be recovered by applying various methods, depending on physical and chemical properties of the minerals. Occurrence properties of copper ore deposits are explained by a simple layer model, from the top to the bottom: topsoil, oxide minerals, and mixtures of oxide and sulfide minerals, with sulfide minerals. High-grade crystalline oxide minerals can be recovered by simple optical sorting and froth flotation. Unused low-grade microcrystalline oxide minerals cannot be processed by traditional froth flotation because of its low economic efficiency. Therefore, a new mineral processing technology is needed. Heap leaching, a conventional mineral processing method, is carried out by piling up oxide ores on an underlay, for example, asphalt, to pour sulfuric acid. The leachate obtained by heap leaching needs to be purified in many steps, results in low economic efficiency and has a great effect on environmental pollution. LPMF processing, a new technology to address problems of conventional mineral processing, reduces the volume of processed substances, and simplifies mineral processing to make resources with existing unused low-grade microcrystalline copper oxide ores. LPMF processing comprises the steps of grinding copper oxide ores to be micronized, and leaching to dissolve minerals in sulfuric acid, reduction of dissolved copper ions onto the iron surface, and then magnetic separation contributes to firstly reclaiming copper concentrates, along with the unreacted remaining iron. Magnetic separation can reduce the amount of minerals processed in the flotation process to about 90% and thus ensure economic efficiency. Copper concentrates with at least 85% of the final copper grade can be reclaimed by froth flotation of the copper concentrate reclaimed by magnetic separation. Let us have a look at the LPMF process in detail. First, complex copper oxide ores are ground to the size easily soluble in acid. Sulfuric acid is used to dissolve copper ions from the copper oxides, because copper oxides are easily soluble in acid. Iron is added to the pulp to reduce copper ions on the iron surface by means of a difference in the ionic tendency of iron and copper. As a result of the reaction, cement copper on iron is made. The property of iron attracted to magnets is used to reclaim cement copper on iron. In this case, because a small amount of gangue minerals are also reclaimed, the grade of the primary copper concentrates is not so high. Therefore, froth flotation is employed to remove gangue minerals but to recover copper. With this process, it is possible to recover copper concentrates with 85% of the copper grade at 74% of the recovery. The LPMF method contributes to economically reclaim copper from unused complex copper oxide ores. While economic efficiency is improved by raising the recovery and the grade of valuable minerals contained in ores, because the grade is usually in inverse proportion to the recovery, it is important to develop a mineral processing method, in consideration of grades and recoveries, to ensure economic efficiency of copper concentrates. The KIGM developed software for assessing the economic efficiency of mineral processing in consideration of mineral grades, initial investment costs, concentrate grades and recoveries.
한국지질자원연구원에서 미유형 저품위 구리산화광을 대상으로 성광 공정에 대한 경제성을 분석한 결과 전통적인 미너럴 프로세싱 기술의 경우 IR 값이 3% 이하로 나타나 매우 경제성이 낮은 것으로 나타났습니다. 그리고 LPF법을 적용하여 IR 값을 분석한 결과 8%인 것으로 나타나 경제성이 다소 향상되었습니다. 그렇지만 한국지질자원연구원에서 LPF법에 자력선별을 적용한 LPMF법의 경우 IR 값이 40% 이상을 상회하는 것으로 나타나 매우 경제적인 성광 공정임을 확인할 수 있었습니다. 이렇듯 미활용되고 있는 저품위 구리산화광을 대상으로 한국지질자원연구원에서 개발한 LPMF법을 적용하게 되면 경제적으로 구리 전광의 품위 및 실수율을 높일 수 있습니다. 따라서 본 기술의 개발을 통해 미활용되고 있는 구리 자원을 새롭게 확보할 수 있고 재련비 절감 및 재료 공정의 간소화를 도모할 수 있는 획기적인 성광 공정이라고 할 수 있습니다.
Depleted high-grade resources prompt us to develop a new, not conventional, mineral processing technology. The Kingdom is developing a new mineral processing technology for the application of unused complex resources through interdisciplinary convergence. The Kingdom further focuses on securing overseas resources through systematic R&D to be a global leader for mineral processing recognized in the world.